Hello everyone, this is Philip from Eclipse Source. In one of our previous videos, we showed you how you can build your custom GitHub Copilot-like AI tool in just under 30 minutes based on the open source tool platform Eclipse Thea, so that your custom tool-integrated AI assistant can really understand your domain concepts and workflows, can read and interpret your workspace projects and artifacts, for instance, to answer questions about it, and can make even edits on your behalf to extend your domain-specific workspace artifacts and models. I'll put the link to the video in the description below. It also has a GitHub repository that you can check out to build your own tool similar to that. In this video today, I want to build on top of this custom AI tool that we've built in the previous video and show you a few things that we usually start out with in our client projects to make the AI responses even more tightly integrated with our tool, more interactive and more visual for our domain users. In particular, we want our users to easily navigate, for instance, from elements that the AI includes in their responses, like when they refer to specific elements. We want to provide links so that they can click on those links and then open a custom editor that shows this particular element within our tool, as if you would open it directly with some Explorer-like view. In addition to that, we also want to provide the AI with the capability to create visual representations of our domain concepts that are as close as possible to how our domain users think about it, and with that provide a much more visual and specialized experience for our users. So, without further ado, let's get started. All right, so the first thing that we want to do is to really integrate the AI responses more closely with the tool. And one of the simplest things that we usually do first is that whenever the AI response references a certain concept in the tool, a domain concept or an element in the model, that it's not just the name printed, but really, for instance, a link that the user can then click onto it in order to open the domain-specific editor within the tool, or to jump to a certain element in the tree and things like that. So, for instance, in our simple example here, where we have an AI assistant that knows the domain model consisting of tasks and nodes and how the tasks are all allocated on nodes and which inputs and outputs they have and so on. We want tasks to be links and then show the editor for the specific task when you click on them. For instance, I can ask now, please give me a list of tasks in this workspace. And now it obtains the tasks, and here it really shows links. And when I click on them, we actually open the editor that allows us to edit those tasks in more detail. Here we just open text editors in your custom tool. We would usually have custom editors, which may be graphical, form-based, or tree-based, or whatever. But here, for the sake of simplicity, we stick with text-based representation, as we really want to focus on the AI aspect of it. So how is that actually implemented? So here we have the code of our agent that we are talking with using the chat. So as we went in much more detail in our previous video, all we need to do is essentially define this agent class here and say it's an abstract stream parsing agent, and specify which language model it requires, and then specify a system message that we want to use for this agent. The system message then also does some in-context learning to teach about the format of the model and so on, and it provides tool functions in order to allow the AI to interact with our tool by, for instance, listing all functions that are in the workspace, and so all tasks that are in the workspace and so on. So now, if we want to, whenever a task is printed in the output, we want to print it as a link. The first thing to do is we want to tell the LLM that it needs to do so. So here we just added a new paragraph that specifies when referring to a task in your output, please link it using the format, and we use here a markdown link format, and specify a URI that identifies one specific task with a specific custom protocol and a format for that link. So that's good. As soon as we put that in, the AI will always print here this markdown link, and since we by default have a markdown renderer in place for outputting the AI responses, this would already show up as a link. However, now what happens when we click that link? We need to teach our tool how to deal with URIs like this. And this is also very simple, because every link click in Markdown in our chat response goes through the normal Eclipse Thea open handler mechanism. So you basically only need to register a new open handler for those specific types of URIs. And how to do that? So first of all, you need to basically, in your dependency injection container, you just go into the module that you have and add a new open handler and provide an implementation for that open handler. And we just create a new file that provides a flow task open handler and register it here. And this implementation is also really simple. So essentially, it needs to implement the open handler interface and then specify can handle, which indicates whether or not this handler should get active for a specific link. And here we basically specify whenever the URI scheme is flow and the authority, that's basically this first element here, this first fragment here is task, then we specify a very high number, otherwise we just return -1. That means we don't want to handle it. And whenever the user now clicks on it, our handler gets invoked, which is really basically just extracting the task URI, the task ID from this URI, obtaining, since we are just opening a file, obtaining the workspace root, finding that file according to our structure, how we put things in our project. So for instance, all task definitions are in the folder task definition. The file name is the task ID and the JSON file. And then we just use the Thea editor manager to open things up. And with that, that's already enough. We just need to rebuild. And from that point on, every single task will be printed out as a link and we can open it. Of course, this can be arbitrarily complex, and you can even invoke commands on click and stuff like that. But that's just a simple example to give you an idea how to do this part. All right, so let's move on to the next step, and that is enabling the AI agent to not just return text, but to present the information that it has for the end user in some other ways. So for instance, tables, diagrams, and so on. Since we are here dealing with tasks that are executed in order and allocated to nodes, we thought a diagram like sequence diagrams or something like that would be a good example to demonstrate this capability. So for instance, here we extended our tool so that whenever we ask something that can be best shown visually, that the AI agent would basically render a diagram instead of just presenting text, because this is very easy to understand for our domain users. We could then, for instance, also ask show how these tasks are allocated to nodes, and basically it would pull in additional information and would basically then draw another diagram that also captures the aspect of the nodes that are executing those specific tasks. So how is that implemented? So similar to the task to the step where we want to print links for tasks, the first step also here is to instruct the LLM what it should do when it wants to when the user asks for visualizing something. Obviously, we go back to the system message and explain to the LLM that whenever the user asks to visualize something like a flow or task to node allocation, to basically print a dedicated element here. Basically, we use this XML-like elements to declare here comes now a section for which we want to render a diagram. And within this element, we then basically instruct the LLM how to specify this diagram. We make it for this simple example very easy for us because we are reusing the mermaid diagram syntax, which the LLM already knows. So there is no additional in-context learning or something like that necessary. So we basically can just reuse that and ask the AI, please use mermaid to show some aspects about our domain model visually and print that in these diagram elements. So now we have those in our response. How do we process them? So here we need to go back to our agent implementation that we have seen already before and extend it with what we call content matchers in Thea AI. Essentially, content matchers are composable little regex expressions, if you want to simplify it, that basically sit between the LLM stream and the chat model, so that whenever an LLM stream comes in, all content matches get asked, do you match? And if yes, then we will create not just plain markdown, but we will create specifically typed content that is put into the chat model that can then later on be rendered differently. So how do they look like? So they have a start regex and an end regex. And then they have two things that they can provide. First of all, they can provide the content factory. So that's essentially a function that translates a fully matched element into an object that is then put into the chat model for rendering. And there is the incomplete content factory that's essentially used when the start is already matching, but the end has not matched yet. And that's a typical use cases to show some sort of in progress message to the user that we are generating a diagram currently, and we're waiting until the diagram generation is finished. So that's basically what we do here. So now we've generated this specific mermaid response content. So that's just basically a data object that we will put here into the chat model. So there will be markdown content objects, and then at some point the mermaid response content object, and then markdown again, and so on. So essentially the only thing that is now missing is to tell how we should render those specific mermaid response content objects. And for that, there is a dedicated registry in Thea AI, which is the chat response part renderer registry, where we can register arbitrary additional renderers. And here we just render an additional mermaid part renderer. Let's have a look at this implementation. So essentially this part renderers, they always again have a can handle method where they specify when they want to get active. And if they tell here, I'm the highest match, then this render method will be invoked for this particular content object. And then here we basically just instantiate a React component that is defined down here. Don't worry too much about this implementation of this React component. It's just an example. But essentially, you can create any React component here based on the input that the LLM generated. And here we just have generic code essentially that renders a mermaid diagram by using the mermaid library that's available. So that's nothing special or specific down here. So that's it for today's video. The full code is available on GitHub, so you can use it as a starting point for your own AI tool. And remember, everything you've seen here is based on Eclipse Thea, which is an open source platform that gives you full control and no vendor lock-in. So you can use it for your own products, internal or external, without any hesitation. If you're building your own AI native IDE, domain-specific modeling tool, or a custom engineering environment, reach out to us. We are happy to support you with our development services to help also your team in building your tailored tools. With that, subscribe for more updates on custom AI native tools, and see you in the next video.